Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 2-2 Extra Practice Number 1 solutions on synthetic division. To figure out the remainder, and then whether it's a factor or the quotient, we're going to use synthetic division. So we'll write down our coefficients to start that process. We've got a 5 for the x to the fourth, minus 3 is the next one. And then we have 4, a negative 1, that's an invisible 1 there. And then finally this 4 gives us a constant. So that's 4 for that coefficient. And our box number is going to be positive 1 because that would zero out our divisor. So we draw a little line, bring down our first coefficient of 5, and then our box number gets multiplied by all the bottom numbers, and we put those answers in the second row. So 1 times 5 gives us a 5 up here. Now we add the first and the second row together. So negative 3 plus 5 gives us 2. 1 times 2 is 2. 4 plus 2 is 6. 1 times 6 is 6. Negative 1 plus 6 is 5. 1 times 5 is 5. And 4 plus 5 is 9. That last number is our remainder of 9. And then that means since it's not 0 for the remainder, that means x minus 1 is not a factor of our polynomial that we started with. For the quotient, we're going to end up with one exponent lower than we started since we divided by x. So instead of x to the fourth, we end up with an x to the third for our first term. So this is going to be all the numbers except the remainder. We have 5x to the third, and then this is 2x squared plus 6x plus 5. To answer this question, we're going to use synthetic division. We'll start by writing down the coefficients. So we have an x cubed as our first term. That's 1x cubed, so we have a 1 for that coefficient, followed by a negative 4 for the x squared. And then we're missing an x term, so we need a placeholder 0 for x, for 0x. We're also missing a constant, so we need a plus 0 for the constant. And then for our box number, since we have x minus 4 for the divisor, then positive 4 is the box number, whatever zeroes out that divisor. Leave some space, draw a line, and bring down your first coefficient. So this 1 is coming down here. We've got 4 times 1, giving us a 4 up here. And then we're going to add these rows. So that's going to be a negative 4 plus 4 is 0. And we multiply this box number by all the numbers that end up down here. So 4 times 0 gives us another 0 up in the second row. 0 plus 0 is 0. 4 times 0 is 0. 0 plus 0 is still 0. So we have a remainder of 0, which means that x minus 4 is a factor of x cubed minus 4x squared. So that's a yes. And then for our quotient, since we divided an x cubed by an x, we end up with an x squared as our first term. This is our coefficient of that x squared, that first number there, so that's 1x squared. And then we have a plus 0x that we're not going to bother writing. We have a plus 0 for the constant. We don't have to write that either. And this last 0 is just our remainder, so that's completely irrelevant. So then x squared is our quotient. To figure out the remainder from this division and all this other information, we're going to use synthetic division. So let me start by writing the coefficients of my polynomial. We have a 2 as our first coefficient, so we'll put that down. And then the x to the fifth also has a 2 for a coefficient. We have a 2, followed by a 3, a negative 3, and I'm checking for placeholder zeros as I go, but I haven't skipped any terms yet. Next, we have a 2 for the linear term, and we should have a constant at the end. Since we don't, that means there's an invisible plus 0, so that means we need a placeholder 0 for that last term. Now for my box number, since x plus 1 is the parentheses here, the divisor, I'm going to use negative 1. Whatever zeroes that out is my box number. Leave some space, draw a line, and bring down your first coefficient of 2. Now we multiply our box number by all these bottom row numbers. So negative 1 times 2 is negative 2. Add the second and the first row there. So 2 plus negative 2 is 0. Negative 1 times 0 is 0. 2 plus 0 is 2. Times negative 1 gives us negative 2. Plus this 3 is going to be 1. Times negative 1 gives us a negative 1 up here. Negative 3 plus negative 1 is negative 4. Negative 1 times negative 4 is 4. 2 plus 4 is 6. Times negative 1 is negative 6. Plus 0 is still negative 6. So after all that, we have a remainder of negative 6. That's not 0, so that means x plus 1 is not a factor of this polynomial. For the quotient, since we divided an x to the 6th by an x, that means x to the 5th is the power of our starting term. So we use these numbers except for the remainder in our bottom row here. So this 2 really means 2x to the 5th for our quotient, followed by 0x to the 4th, but we're not going to bother writing that, followed by 2x cubed plus 1x squared, so just x squared then, minus 4x plus 6, and this last one was our remainder, so we're done. To solve this problem, we will use synthetic division. So we'll start by writing down our coefficients for the polynomial. This is 1x to the 4th, so we start with a 1, followed by negative 3, plus another 1, so positive 1. And then we're missing an x term, a linear term, so we actually have a 0 placeholder there because we have a 0x we're not writing. And this negative 5 constant gives us negative 5 for our coefficient. For our box number, since we're dividing by x plus 2, our box number is what zeroes that out, so negative 2. And then we leave some space and draw a line. Now we can actually do the number crunching. Let's bring down that 1 to start with, our first coefficient. We multiply our box number by all the bottom row numbers we get, so negative 2 times 1 is negative 2. Now we add the top 2 rows. Negative 3 plus negative 2 is negative 5. Times negative 2, that's going to be 10. Plus 1 gives us 11. Negative 2 times 11 is negative 22. Plus 0 stays negative 22. Negative 2 times negative 22 is 44. And then add that to negative 5 to get 39. That last number is our remainder of 39. Since that's not 0, it means x plus 2 is not a factor of our polynomial. And for the quotient, that's going to be all the numbers except the remainder. So we have a 1 for the first coefficient. That's going to be 1x to the 3rd because we started with x to the 4th and divided that by an x. So now we're down to a 1x cubed minus, this is going to be minus 5x squared plus 11x minus 22. For this problem, we're trying to do this division. I'm going to use synthetic division to make it a little bit easier. So let's start by writing down our coefficients. We've got a 3 for the 3x cubed, and followed by an 11, a 5, and a negative 3. No missing terms, so no placeholder zeros. For our box number, this is probably the trickiest part of this problem. Since our divisor is 3x minus 1, we need whatever is going to zero this thing out. So if you set this divisor equal to 0 and solve, add 1, divide by 3, we end up with a box number of positive 1/3. And now we leave a little room and draw a line, and we start our synthetic division. So we'll start by bringing down our first coefficient of 3, and now I multiply my box number by all these bottom row numbers. So 1/3 times 3, well, that's basically 3 divided by 3, which is just 1. So that goes up here in the second row. Now we add the top 2 rows together. 11 plus 1 is 12. 1/3 times 12, 1/3 of 12 is, let's see, 4, so that's up here. 5 plus 4 is 9. 1/3 times 9 gives me 3. Negative 3 plus 3 is 0. So that 0 at the very end, that's our remainder. Since we have a remainder of 0, that means 3x minus 1 is a factor of this polynomial. And now to write the quotient, we're going to start with this 3 here. That's the first coefficient of our quotient, and that's going to be 3x squared because we started with x cubed and divided by an x. So we have 3x squared plus, this is 12x plus 9. To perform this division and find the remainder, whether it's a factor and the quotient, we're going to use synthetic division. So we start with our coefficients. We have a coefficient of 1 to start with because we have a 1x to the 5th. Followed by, well, we don't have an x to the 4th term, so there's a 0 for that. We don't have an x cubed, so there's another 0 for that. We do have an x squared, so we have a negative 3 for the next coefficient. We're missing the linear term. There's a 0x that we're not writing, so we have another placeholder 0. And this negative 11 gives us our last coefficient. For the box number, whatever zeroes out this divisor gives us that, so that's going to be positive 2. Leave some space, draw a line, and now let's bring down our first coefficient of 1. We multiply our box number by these bottom row numbers. So 2 times 1 gives us a 2, and we'll put that up in the second row here. Now we add these top 2 rows together. 0 plus 2 gives me a 2 back down here. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. Negative 3 plus 8 is 5. 2 times 5 is 10. 0 plus 10 is 10, and 2 times 10 is 20. Negative 11 plus that's going to give us a 9 down here, and that 9 is our remainder. Since it's not 0, that means x minus 2 is not a factor of this polynomial. For our quotient, that's all the numbers down here except for the remainder. So this 1 is our first coefficient of the quotient, and that's going to be a 1x to the 4th power because we started with x to the 5th and divided by an x, and now we're down to x to the 4th. And now we have a 2x cubed after that, and a 4x squared. This 5 is really 5x. This 10 is playing itself in this motion picture. That's just a plus 10. And this 9 is not even part of it because it's the remainder and doesn't get used in the quotient. For this problem, to find the remainder and all this other information, we're going to use synthetic division. Let's start by writing our coefficients. This x cubed means we have a coefficient of 1x cubed, followed by negative 8 and negative 18, and then finally this 25 here. For the box number, we're going to use negative 3 because that zeroes out x plus 3. Leave some space, draw a line, and bring down your first coefficient. Box number gets multiplied by all the bottom row numbers, so negative 3 times 1 is negative 3. Top two rows get added together, so negative 8 plus negative 3 is negative 11. Negative 3 times negative 11 is 33, plus negative 18, that's going to be 15 down here. Negative 3 times 15 is negative 45, and 25 plus negative 45 is negative 20. So that's a remainder of negative 20, because that's our last number in the bottom row. Since that's not 0, that means x plus 3 is not a factor. And for our quotient now, that's going to be all the numbers except for the remainder. So this is going to be a 1x to the, let's see, we started with third power divided by an x, and now we're down to 1x squared. Followed by, this is negative 11x, and then plus 15. For this problem, we want to know if x plus 1 is a factor of this large polynomial. So using our remainder theorem, we know that the remainder, which is what we need to figure out if we have a factor or not, the remainder that we get when we divide by x plus 1 is going to be the same number that we would get if we just plugged negative 1 into the polynomial. So we're going to figure out the remainder by just plugging negative 1 into this expression. So 6 times negative 1 to the 95th plus 2 times negative 1 to the 26th plus 11, all of that. And we'll see if this comes out to 0 or not. So for this first one, negative 1 to the 95th is just negative 1. 6 times negative 1, that's a negative 6 for that first term. Negative 1 to the 22nd in this second term, that's a positive 1. So we're doing a plus 2 there. And then finally, plus 11 is still hanging around. Negative 6 plus 2 is negative 4. Negative 4 plus 11 is 7. That's not 0. So that means that x plus 1 is not a factor of this polynomial because we get a remainder that is not 0.